quick review video on finding the interval for a rational function. Remember, a rational function is something like this, where it's polynomial on top, and the numerator and a polynomial on the bottom. In this case, I've already factored it, so it is one term with four factors, 2 in the numerator, 2 in the denominator. A couple things right away. This is a review video, so I'm assuming you know that zeros occur when the numerator is equal to 0. So just looking at the top, here in the red, we can see that the two zeros of this function are 2 and -3. Likewise, we understand that rational functions cannot have the denominator be 0. Thus, the bottom cannot equal -5 or 4. And those four numbers set everything we do. So we know that -3 is equal to 0, and we know 2 is equal to 0. So right away, I know those 2 points. It leaves 5 intervals to talk about. 1, 2, 3, 4, 5. And you notice I have some purple points down here because I'm going to consider 1 point in each of the intervals and do the sign. Now, there's a couple ways to do this. You literally could just sit here and take in -10, -10, -10, -10, negative, 4 negatives is a positive. And then if I get rid of all this stuff down here, I can rinse and repeat, like a shampoo. If you read a shampoo bottle, it says your best results, rinse and repeat. Next one I check is -4. Then I get negative, positive, negative. 3 negatives and a positive is a negative. And I can go through and define the intervals like that. But often, and in my classroom, I say I want a sign table, and that's S-I-G-N, sign. So I don't want this to happen. What I want to have happen is I want to do the factors independently. So we bring out a big sign box. All right? And I write down the factors across the top. X plus 3, X minus 2, X plus 5, X plus 4. And I don't need to have the parentheses, so I can get rid of that and write X plus 3, nice and big. And what I can do then is we want to think about this side numbers here. And I'm going to just take it, I'm going to copy this, and I'm going to paste a new one, and I'm going to rotate it. And those side numbers actually end up right here in the X. And I'm going to delete the number line, and you notice that then it works kind of, we rotate that number line in our minds. And we already know the zeros. I'm going to remark those immediately. Those zeros of -3 and 2, boom, 0, 0. And likewise, up here I should have said these numbers are open circles. They're completely undefined. Can't happen ever. So I put those undefineds in. And then I work by column. I know X plus 3 is positive above here, and I know it's negative here. X minus 2 I know is positive above 2 and negative below. X plus 5, positive above, -5, negative below. X minus 4, positive above 4, but negative everywhere else. And I can go across now. 4 negatives are positive, negative. We already knew those two. Next line, right here, this interval, is 2 negatives is a positive. 3 positives and a negative is a negative. And finally, the last one's all positive. All right, $1 million question. This hunk of junk was greater than or equal to 0. All right, so I want it where it's positive, and I want it equal to 0. So I already knew it 2 zeros. So 0 and positive, 0, positive, positive. So I got, starting this way down, all right, going down the page, I start at -infinity, and I go to -5. My next interval is including -3 and including 2, kind of a neat one. My last interval starts at 4, not including 4, and going to positive infinity. And again, we can check this. Again, very quick review. Assumes you already know what you're doing. If not, go back and look up rational inequalities and have someone go through it slower. Keep practicing. Pre-calc is fun.